Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is meant as a review of concepts from your trig class. As such, I do not delve into the proofs of theorems, nor do I go into excruciating detail with examples. If you've never had a full course in trig, and you're currently in a pre-calculus course, I highly recommend watching my trigonometry playlist on YouTube, as it goes into greater detail with all of my trig concepts. Again, trig is so important for calculus that having a shaky background in the subject will lead to abysmal results in calculus. With that said, let's hop into this review of trigonometric functions. I was supposed to be trigonometric functions, but whatever. And this one specifically is the third and final definition, called the point definition. That's what I call it. And by the way, I can easily see right now, this should have changed to the point definition. All right, so I'll write that in here. All right. Point definition is very much like the unit circle definition. That's why I copied and pasted and just modified it here. So point definition and unit circle are so close to each other that I usually cover the point definition when I talk about the unit circle definition. Let theta be any angle in standard position, and P, the point XY, be a point on the terminal side of theta. If we allow R to be the square root of x squared plus y squared, and if you notice, that is actually just the hypotenuse of a right triangle. So R is, for example, we have a right triangle right here. This distance is x, that distance is y, this distance is r. Then x squared plus y squared is equal to r squared, or in other words, r is equal to, generally speaking, plus or minus the square root of x squared plus y squared. However, r is a hypotenuse, it will always be positive. So r is equal to the positive square root of x squared plus y squared. That's where that comes from. Anyway, that's the distance from the origin to some point P. Then the trigonometric functions of theta are defined to be: sine of theta is the y value of that point over the over the radius, or the hypotenuse length, if you will. Cosine is x over the radius. Tangent is y over x, where x is non-zero. And then you have the reciprocal functions. So there's not much I need to say about this, other than if you're given a point in space. So this is maybe it's good to clarify the difference between the three definitions. That's probably better, right? So when you first learn trigonometry, if you learned it in high school, people love, for some reason, the unit circle definition. It's an okay definition. It's great for calculus, but it's not great for learning trigonometry. And so the unit circle definition says, okay, well, we have this circle here, and its equation, by the way, is x squared plus y squared is equal to 1. And if you pick a point on that unit circle, the point should satisfy that x squared plus y squared is equal to 1. But we're going to label the trigonometric functions based on points on the unit circle. So the unit circle definition, I'll write it this way, unit circle definition. This is just to clarify, to get things cleared up for your brain, that the way the unit circle works is that you have an arc length here, and that arc length we'd call t. And this would cut out an angle. And that angle, if it's measured in radians, is the same as the arc length. Again, because there's this relationship between arc length, radius, and angle in radians. That's just a recall from something we've talked about previously. And therefore, the angle in radians is arc length over radius, but in a unit circle, radius is 1. So the angle is just equal to the arc length. So for arc length, we call it t. The angle would be t, again, in radians. And that allows us to define our trigonometric functions in terms of the arc length or the angle t. Sine of t would be y. This is again for unit circle. Cosine of t would be the x value. Tangent of t would be y over x. And then you have the reciprocal functions, which I won't even bother with. And then generally, when I talk about this in a trig class, I then say, well, what if that circle wasn't unit anymore? What if instead we had a circle? And let me actually just create a circle here really quickly. So what if we had a circle that instead of being a unit circle was a circle of radius r? Okay, so here's my circle, and I'll turn that off now. And the radius of this circle is, instead of 1, we'll call it r. So this is r comma 0, and this is 0 comma r. Well, the equation is x squared plus y squared is equal to now r squared. Oh, well, okay. We still can have a point on here, right? It still can happen. And we could still define the trig functions in terms of those points. It just requires us to normalize the circle. So this radius is r, and we can then say, okay, well, instead of the arc length, talking about the arc length, because the arc length here, let me show this. If this arc length was t, this angle is not going to be t. That's the problem. That angle and arc length match only on the unit circle. Again, if the radius is 1, the angle and the arc length match if the radius is 1. If the radius is not 1, the angle and arc length will not match, and so we cannot talk about arc length here anymore. We have to talk about angle instead. Because, again, the angle and arc length don't match. The arc length is some s, the angle is a theta in radians. So what we're going to go ahead and do is define the trig functions this way. Sine of that angle theta is the y value over the r value. The cosine of that angle theta is the x value of that point over the radius. And then finally, the tangent of theta is the y value over the x value. Now, I'm imploring that you take a moment to consider that these two are the same definitions. If the circle that we consider on the right-hand side has a radius of 1, then sine of theta is y, cosine of theta is x, and tangent of theta is y over x. Nothing has changed. Now, I think the thing that ties these together, honestly, is right triangle trigonometry. In right triangle trigonometry, the weakness of it is that it only exists for acute triangles. In other words, triangles that have angles less than 90 degrees. Right triangles that have angles less than 90 degrees, other than the right angle itself. So acute right triangles. So the right triangle trig definition, just to kind of pull it all together, you have an angle that's less than 90 degrees because you already have a 90-degree angle in this right triangle. And we define the sine of that angle to be opposite over hypotenuse. So opposite over hypotenuse. And the cosine of that angle is defined to be adjacent over hypotenuse. This is adjacent side to that angle, hypotenuse. And then the tangent of that angle is defined to be opposite over adjacent. Now, if you just use the right triangle trig definition and compare it to the others, it is actually the same definition. Going here, so this adjacent length is x, the opposite length is y, hypotenuse is 1. The sine of t is opposite over hypotenuse, y over 1. The cosine of t is adjacent over hypotenuse, x over 1. And the tangent of t is opposite over adjacent, y over x. And those are the actual definitions off to the right-hand side there. Same thing over here. If this was our triangle, let's see, sine is opposite over hypotenuse, y over r. Cosine is adjacent over hypotenuse, x over r. And tangent is opposite over adjacent, y over x. And again, having said all of that, For some reason, my eraser is just not working today. You see those trig values down below. So this ties together all three definitions of trigonometry. They're all the same definition. It's just a case-by-case basis of which one you want to work with. I almost exclusively work with right triangle trigonometry. It's just a habit of mine. You could survive all of trig with right triangle trigonometry. It is important to know the unit circle though. So just to let you know, that will become important because you're talking about circular functions, and eventually in calculus, you'll deal with hyperbolic functions. So it is important to know that stuff.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much, that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.